Hi everyone, this is your math guru. Please don't forget to subscribe below for more easy to understand math concepts. Today we're going to discuss arithmetic progression. An arithmetic progression is a sequence in which the difference between any two consecutive terms is common. This constant is denoted as d. In the example below, we have 2, 4, 6, and 8 as a sequence. To jump from 2 to 4, we are going to add 2. To jump from 4 to 6, we have a difference or a common difference of plus 2. And also to move from 6 to 8, we are going to have plus 2. Thus, in this example, a common difference, d, which is also the same thing as finding the difference between two consecutive terms. And in this example, we have 4 minus 2 or 8 minus 6 is going to give us 2. So therefore, our d is plus 2. Our first term, denoted as T1, is also our a, and in this example is 2. Our second term, T2, equals, we are going to add the common difference 2 to our first term, which is going to give us a plus d. Our third term, which is T3, equals a plus 2d. Thus, to find our nth term, Tn, the formula is going to be a plus n minus 1 d, where d is our common difference. Watch out for my next video, where I'm going to show you how to derive the sum of the arithmetic series, and the formula is n over 2 in brackets 2a plus n minus 1 d. For this video, we are going to focus on finding the nth term, finding the common difference, or finding a value in the sequence. In our first example, we have considered the arithmetic sequence 2, 6, 10, and 14. The first question says, what is the common difference? A common difference is the difference between two consecutive terms, that is the term in front minus the term behind. For this question, we are going to have 6 minus 2. This must also be equal to T3 minus T2, which is going to give us 10 minus 6. Thus, our d is going to be 6 minus 2 is 4, and the confirmation is 10 minus 6, which is also 4. Our second question says, state the value of the next two terms of the sequence. The last term for the sequence is 14, and because the common difference is 4, we are going to add 4 to the last term, which will tell us what the next term in the sequence is. 14 plus 4 is 18. The next term after 18, we are going to add a common difference again, which is 4. 18 plus 4 is 22. The third question says, derive the formula for the nth term of the sequence. Remember, to find the nth term for arithmetic progression, the Tn is going to be Tn equals a plus n minus 1 d. For this question, our a is the first term, which is 2. Our d is the common difference as calculated in the first question, which is plus 4. Substituting this back into the equation, we have Tn equals 2 plus n minus 1, 4. Expanding the equation, we have 2 plus the 4 outside is going to multiply all the terms in the bracket, minus 4. And collecting like terms, we're going to have Tn equals 4n minus 2. In the fourth question, we have determine the value of the 25th term. From using the formula derived in question 3, we have Tn equals 4n minus 2. Because we are looking for the 25th term, our n is going to be 25. We are going to substitute n equals to 25. In the question, we have 4 times 25 minus 2. This is going to give us 100 minus 2. Therefore, our T25 or the 25th term is going to be 98. Number 5, we have which term has a value of 46. Using the same formula, we have Tn equals to 4n minus 2. Because we are looking for the term that has a value of 46, our term is going to be 46 equals 4n minus 2. We are looking for n, or the nth term. Using the balance method, we add 2 to both sides. We have 46 plus 2 equals to 4n. This will give us 48 equals to 4n. And dividing both sides by 4, we are going to have n equals to 12. Thus, the 12th term is going to give us 46. Let's look at another example. In this example, we have considered the arithmetic sequence 3x minus 1, 5x minus 2, 4x plus 1. 1. Determine the value of x. Because it's an arithmetic progression, our d is going to be common. Our first term is 3x minus 1, our t2 is 5x minus 2, and our t3 is 4x plus 3. To find our d, which is a common difference, we are going to have t2 minus t1 must be equal to t3 minus t2. Substituting back the expression, we have 5x minus 2 minus, in bracket, 3x minus 1 must be equal to 4x plus 3 minus, in bracket, 5x minus 2. Note the use of bracket because it's an expression and we must take note of the signs. Expand on the bracket, we're going to have 2x minus 1 equals minus x plus 5. Moving all the x to one side, we are going to have 2x plus x equals to 5 plus 1. 3x equals to 6. And dividing both sides by 3, we are going to have x equals to. In the second question, we have if x equals to 2, determine the formula for the nth term in the series. From the first question, we know that x equals to 2. We are going to substitute x equals to 2 to get the real values for our sequence. We have 3 times 2 minus 1, which will give us 6 minus 1. 5 times 2 minus 2 for the second term. That will give us 10 minus 2. And for the last term, we have 4 times 2 plus 3, which will give us 8 plus 3. The first term is going to be 5. The second term is going to be 8, and the last term is going to be 11. Our first term, 5, 8, 1, using that sequence, is going to be 5. Our common difference is going to be 8 minus 5, which is also 3, or 11 minus 8, which is also 3. Using the formula for the nth term of an arithmetic sequence, we have Tn equals a plus n minus 1 d. Substituting the value of a and d, we are going to have 5 plus n minus 1, 3. Expanding the bracket, we have 5 plus 3n minus 3. Therefore, our Tn is going to be 2 plus 3n. The third question says, determine the value of the 15th term. 3. From a formula, we have Tn equals to 2 plus 3n. Substituting n equals to 15, because we are looking for the 15th term, we are going to have T15 equals to 2 plus 3 times 15. This will give us 2 plus 3 times 15 is 45. Therefore, our 15th term is going to be 2 plus 45, which is 47. For our last question, it says, which term has a value of 302? Using the same formula from the previous question, we have Tn equals to 2 plus 3n. Now our term is 302. We are looking for which term is going to give us 302. Substituting into the equation, we have 302 equals to 2 plus 3n. Using the balance method, subtract 2 from both sides. We are going to have 302 minus 2 equals to 3n. We have our 300 equals to 3n. Dividing both sides by 3, we are going to have n equals to 300 divided by 3 is going to give us 100. Thus, the 100th term is going to give us 302. Let's try out the challenge question below. It says, consider the pattern 5, 12, and 19. 1. Find the formula for the nth term, and 2. Find the nth term. You can pause the video and solve it out yourself. For the first one, you're going to have Tn equals 7n minus 2. And for the second question, the nth term, or the 10th term, is going to be T10 equals 68. Thanks for watching. Bye.